Hi guys, welcome back. It's Miss Hill again, and we are continuing with our linear functions. Today our focus is going to be on graphing linear equations from the three different forms. So we're going to have a quick review of the slope-intercept form, point-slope form, and standard form, seeing what information we can get from each of those forms, making it super quick and easy to graph. And then tomorrow we'll talk more about writing equations in the different forms. So going back, just a quick review, linear functions. Remember that linear functions do not contain variables with exponents, so there are going to be no exponents in any of the things that we're working with. There won't be any variables in the denominators if we have a fraction, and we won't have a product of variables anywhere in our equation. If you see one of those, that means that you don't have a linear function, and we'll see those in future units. But looking at our three different forms for things that we do know are linear equations, our slope-intercept form most of you guys are most comfortable with, and that's your form y equals mx plus b. So in our slope-intercept form, it's telling us that we have the slope and the y-intercept when we're in that form. Our slope is represented by the variable m, and keep in mind that means that we're talking about the rise over the run. And our rise is going to be going up or down, while we're always going to run to the right. And then our y-intercept b, that's the point where our graph crosses the y-axis. And that's our starting point that we're going to use to graph. Alright, so again, y-intercept, the point where that line crosses the y-axis, that's our starting point. So we're going to start by plotting the y-intercept. And that's our b value. And then from there, we're going to use our slope, the m, with the rise over the run to find some more points and then connect them with some lines, or with a line. So we're going to use slope to find more points, and connect it with a line. Alright, and again, that's the one that we're most familiar with. We tend to use that one most often. And when in doubt, you can always solve for y and put it into slope-intercept form and use those two given values to create your graph. The next form that we're going to talk about is point-slope form. Notice that we have y minus our y1 value is equal to m times, in parentheses, x minus our x1 value. So the two things that we're given are the slope, m, and then our point on the line, x1, y1. So to graph this, instead of starting by plotting the y-intercept, we're going to plot the given point. And again, that's your x1, y1. And then we're going to use our slope to find a couple more points and draw that line. So very similar, just a different form giving us that point to plot first, use our slope to connect, or to find more points, and then just connect them with a line. So if you see y plus or minus a number and then it's equal to something times x minus or plus another number, that's your hint that you're in point-slope form. Then the third form will be our standard form, and that's where we have ax plus by equals c, where a, b, and c are all integers, very important. And also we want to keep in mind that a is going to be positive. So if you have some number times x plus another number times y is equal to c, you don't have any fractions or decimals in there, and your a value is positive, then you are in standard form. And this is when you're going to want to use your x and y intercepts, keeping in mind over here that the x-intercept is a point where y is equal to 0, and your y-intercept is your point with x equals to 0. So finding our intercepts, the first thing that we want to do for the x-intercept, remember when we're on the x-axis, y is 0, so we're going to let y be equal to 0 and solve for x. So if you think about it, we're letting y be 0, so that means I can forget about that because any number times 0 is just 0. So if ax equals c, we'll divide both sides by a, or simply c over a, and that's going to be our x-intercept. Then we want to repeat with the y-intercept, but this time remember with the y-intercept, we're on the y-axis and x is equal to 0. So if we let x equal 0 and solve for y, we're looking at our ax plus by equals c. If x is 0, then that's gone, and we just have by equals c. So we would be dividing both sides by b to find our y-intercept, simply giving us y equals c divided by b. So that means our y-intercept is going to be our c value divided by the b value. And then it's very easy to graph once you have your intercepts, because all you have to do is plot each intercept and then just connect them with the straight line. And then you don't have to worry about making a table of values or changing to slope-intercept form or anything like that. If you use the information that's given based on the form of the equation that you have, then it's going to be much easier to graph and it's going to take a lot less time. So if you were graphing from any form, when in doubt, you can always make a table of values, choose your value for x, and find the y. So in any form, you could always make that table, pick any values you want for x, substitute them in, find the values for y. There's your ordered pairs that you can graph and create your graph that way. It just takes a lot longer. Some other things that we want to remember as we are creating these graphs. We already talked about slope was rise over run, but don't forget we can use the formula y2 minus y1 over x2 minus x1. So that's a big thing to remember. Also keep in mind, with some of these we will be talking about horizontal and vertical lines. So our horizontal line is going to have a slope of 0. Horizontal line is the one that's going to cross the y-axis, and your equation is always going to be in the form of y equals some number. If it's a vertical line, on the other hand, remember that's where your slope is undefined. It's going straight up and down. It's not going to pass the vertical line test. So that means it is not a function. Your line is going to be crossing the x-axis, and your equation is going to be in the form of x equals some number. Then we're also going to be talking about parallel and perpendicular lines, keeping in mind parallel lines have the same slope. My little trick that I used to remember this when I was back in school taking my math classes, I remembered parallel had the 2 L's in there. Same slope, 2 S's. That was just my trick for remembering. And then perpendicular lines, they're going to have slopes that are opposite reciprocals. So they're going to have opposite signs, and then the numbers have flipped, if you will. When they're multiplied together, it's going to be equal to 1. So for example, 2/3 and 3/2, they're reciprocals. You multiply them together, you have a product of 1. So let's take all this and put it together, and let's get some practice. And tomorrow we'll talk about the writing equations. So let's look at the graphing equations practice. And we're not going to work through all of these. You can check the answers for the ones that we don't work through on Blackboard. But we'll work through a couple of each just to give you an idea of what's going on and kind of refresh your memory from Math 1. So let's start with number 1. And we'll write number 1 here. Our equation is y equals 2x minus 3. Now we can kind of cheat here and see, oh, we're in slope-intercept form, but we're in that form of y equals mx plus b, so we know it's slope-intercept form. And the key things that we're going to get from slope-intercept form are the slope and then the y-intercept. So our slope is the coefficient of x, which is 2, and our y-intercept is the constant at the end, minus 3. Now keep in mind that is an ordered pair, so we want to write it as an ordered pair 0, negative 3. The x-intercept we're not getting directly from our equation, so we're going to ignore that for right now. So remember we said once we have those two pieces of information, that's what we're going to use to graph it super quick and easy. So we're going to start at that y-intercept of 0, negative 3. And then from there, using our slope of 2, remember that means that we're going to go up 2 to the right 1 for that slope of 2. So up 2 to the right 1, there's a point. Up 2 to the right 1, there's a point. You can put as many as you want, but 3 is a pretty good number. And we'll just connect those with the line. And since we can go forever in each direction, we're going to draw the arrows. So if we wanted a table of values here, we can easily start out with our y-intercept at 0, negative 3. And then other points that we got using our slope, we have 1, negative 1. And then we also have 2, 1. We can see that with the domain and range here, the x value, since I go forever in each direction, our domain we can simply write as all real numbers. You can either write out all real numbers or you can use the symbol. It's a funny looking R. And then remember we talked about yesterday, our degree for any linear function is going to be 1. So we should get all of those questions right on any quiz or test that we have. Domain and range. As long as we're talking about just the general equation, all real numbers, degree of any linear function is going to be 1. Then looking at our end behavior, as our x values get smaller and smaller as we're going to the left here, we can see that our y values are also going down. So y approaches negative infinity. You could also say that it's going down or decreasing. I'll accept either of those as the correct answer as well. It lets me know that you understand what's going on. And then on the other hand, as x approaches positive infinity, so as x is getting bigger, we can see that our y values are increasing. So our y values are going to positive infinity, or we could say they're going up or increasing. Alright, so there's one of our slope-intercept form functions. Let's look at another one just to get some more practice. Let's look at number 3. So we'll write this one over here, and again, numbers 2 and 4, you'll be able to check your answers on Blackboard. So if we have the equation y equals negative 1/3 x plus 2, again, we are in slope-intercept form, that y equals mx plus b. We can see that our coefficient of x gives us our slope of negative 1/3, so that means we're going to be going down 1 to the right 3, and our y-intercept, the constant, is 2. We don't need to worry about the x-intercept when we're in slope-intercept form. We're just going to go straight to our y-intercept that we should be writing as an ordered pair. We'll fix that. We're at 0, 2. So we'll plot that point first. And then using our slope of negative 1/3, we'll go down 1 to the right 3. And then let's get another point down 1 to the right 3. And again, we can connect those with a straight line. We'll include our arrows showing that yes, domain and range are still all real numbers with the degree of 1. So the points that we drew on our line, we started at our y-intercept of 0, 2. Then moving down 1 to the right 3, that puts us at 3, 1. And then our last point was at 6, 0, our x-intercept. But since we did not get that from the equation, we're not going to put that in the key parts from the equation section. And our end behavior here, looking carefully as x goes to negative infinity, so as our x values get smaller, our y values are increasing. They're going to positive infinity. So up or increasing. And then as our x values are getting bigger, as we're going bigger, then our y values are going down or decreasing. So y approaches negative infinity. And again, on the quiz or the test, if you can tell me the direction that it's going appropriately, I will count that if you're not using the symbols. It lets me know that you understand what's happening in the graph. Okay? So now let's look at some equations that are in standard form. That's our ax plus by equals c. So keep in mind a, b, and c, they're all integers. A and b are not going to both be 0, and that a value is positive. So let's start with number 5. For number 5, we have 5x minus y is equal to 10. This is in standard form. X and y are on the same side. No fractions or decimals. My a value is positive. So remember, standard form, we're not going to be able to see the slope very easily, but we can quickly find the x and y intercepts. So for the y-intercept, remember we're going to let x be 0. So if we say 5 times 0 minus y equals 10, then we can forget about the 5 times 0 and just say if negative y is equal to 10, that means that y is going to be positive 10. So that means that our x-intercept is going to be at 0, 10. Then we're going to do the same thing for the x-intercept. We're going to let y be equal to 0. So that means we have 5x minus 0 is equal to 10. So if 5x is equal to 10, then x is simply 2. So that means our x-intercept is at 2, 0. So we can easily graph these points. However, our scale, 1, 2, 3, 4, 5, 6, 7, 10 is going to be off of the grid. So if I change, and I see that that should be at negative 10, not positive 10. We'll fix that real quick. Negative y was positive 10, so y is going to be negative 10. We're going to change our scale so we can see 10 and go by 2s. So 2, 4, 6, 8, 10 there. Negative 2, negative 4. And on the y-axis as well. So now we can plot those points. We have our y-intercept at 0, negative 10, now that we fixed that. And then our x-intercept is at 2. And then we can connect those 2 points. And then we have those 2 points that are on our graph, so we can add those to our table. To 0. And then from the graph we can fairly quickly pick out another point and see, oh, well, it looks like about here at 1, 5, or 1, negative 5, excuse me, we would have another point that's on our grid. Or if you follow that same going up 10 to the right too, using that slope that we could easily figure out, then we could go up to 4, positive 10. But either of those points work. So I'm going to use that 1, negative 5 because I can see that on the line that we drew. Just like with our other functions, we have a linear function with domain and range of all real numbers. Degree is 1. And then looking at our end behaviors, as our y value goes to the, as the x values goes to the negative, our y value also goes to the negative. So it goes down or it's decreasing. And then as our x values increase going to positive infinity, so do the y values. So y approaches positive infinity, or we can say it's going up or increasing. All right. Let's look at one more in standard form. Let's look at number 7. So for number 7, we have x plus 3y is equal to 3. So So again, we're not going to worry about the slope. We're simply going to look at our x and y intercepts. So if we look at the y-intercept, remember that's where x is equal to 0. We're left with 3y equals 3, so that means that y is equal to 1. So we have the ordered pairs 0, 1. And then if we say that for the x-intercept that y is 0, that means we have x is 3. So our x-intercept is at 3, 0. So we're going to start by plotting those 2 points. We have a point at 0, 1 right here, and then 1, 2, 3, 0. We can connect those 3 points, or 2 points, with a straight line. Something like that. So with our points at 0, 1, and 3, 0, we can see, oh, we have a slope of negative 1/3, down 1 to the right 3, so we can quickly find another point at 6, negative 1. And again, domain, all real. Range is also all real with the degree of 1. And then looking at those end behaviors, as x gets smaller going to negative infinity, y goes to positive infinity because our graph is going up or it's increasing as we go to the left. Then as x goes to positive infinity, the bigger the x value is, the smaller the y value is. So y is approaching negative infinity, going down or decreasing. And there's a couple of examples of standard form. Again, the other examples will be on Blackboard. You can check those answers there if you want the extra practice. Now let's look at point slope form. And this is where we're in the form of y minus y1 equals m times x minus x1. So looking at number 9. If we're in the form of y minus 3 equals 2/3 times x minus 6. And our point slope form. We're going to be able to find the slope and not the x or y intercepts. We're just going to have the point x1, y1. So we're going to list that point. So our slope that we're given is 2/3. And then the point that we're given, remember it's y minus y1 is equal to m times x minus x1. So we're going to use the opposite sign. So x minus our x1 value of 6. So there's our x1 value of 6. And y minus our y1 value of 3, y minus 3. So the point that we're given is 6, 3. So 1, 2, 3, 4, 5, 6, up 3. And then we have a slope of 2/3. So we're going up 2 to the right 3. We're going to go off the grid just a little bit there, but we can go backwards down 2 to the left, 1, 2, 3, and we can get another point just in case, down 2 to the left, 3. And that actually lets us see our y-intercept. So that'll give us 3 points on the line. So we have our 0, negative 1 that we found for the y-intercept. And then we had the point 3, 1. And then the point that was given to us, 6, 3. Again, just like all of our other linear functions, domain and range are both all real numbers. Degree is 1. And then looking at our graph, we can see the end behavior as x goes to negative infinity, y goes to negative infinity. So going down or decreasing. And then as x goes to positive infinity, so does our y value. And there's a point slope form equation. Let's do one more, and then we'll look at some other types of equations you might run into. So for number 11, y plus 6 is equal to negative 3/2 times x plus 6. So again, point slope form. We will get the slope but not our intercepts. We'll just have the point that's given. So from our equation, we can see our slope is -3/2. The point they gave us, the x minus our x1 value, so keep in mind x minus a -6 is the same thing as plus a positive. So that means our x coordinate is going to be at -6, and then our y value is also going to be at -6, because y minus a -6 is the same thing as plus a +6. So we'll start by plotting that point of -6, -6. And then using our slope of -3/2, again, this is going to take us off the grid. We could have changed our scale if we wanted to, but I'm just going to go backwards and go up 3, to the left 2, to get another point on there. I can kind of estimate where if I went down 1, 2, 3, to the right 2, it's going to be somewhere around there. So using the point that they gave us, -6, -6. And then I could figure out that I also have a point at -8, -3. And I could go the other way and say I have a point at -4 and then -9. Again, domain and range, all real numbers with the degree of 1. With our in behavior, as x approaches -infinity, y approaches +infinity, or we're going up or increasing. And then as x goes to +infinity, y goes towards -infinity, or it's going down or decreasing. And there are the point slope forms. All right, there will be some equations that are not in those forms. Remember, we talked about our horizontal and vertical lines, or something that just is not in any of those forms that we talked about. So if we look at number 13, when we're in the form of 6y equals 12, I only see one variable. So that's my first clue that I have one of those other forms. But if I solve for y, then I'm simply left with y equals 2. So keeping in mind that when we have something like y equals 2, or y equals any type of number, then that means we're going to have a horizontal line, if we want to be more specific. And with that horizontal line, remember our slope is always 0, and our y-intercept is going to be at 0, 2. So we just have our point at 2, horizontal line passing right on through. It doesn't matter what our x value is, our y value is always going to be 2. So we could have 0, 2, 1, 2, 2, 2. Doesn't matter what value you choose for x, your y value is always going to be 2. Now with these other type of equations, domain and range are going to be slightly different. We want to pay close attention to these. And see that with our domain, we can use any x value that we want. So that's still going to be all real numbers. But the range does not change. It's constant. All we have is y equals 2. So with that horizontal line, slope of 0 degree is 0. And our in behavior, you can either write constant or adjust that y is equal to 2. Our y value does not change. Number 14 is kind of along those same lines, where we have 5x minus 20 equals 0. I only see that one variable, so that lets me know it's one of those other type equations. But if we were to solve for x, we'd wind up with x is equal to 4, letting us know that we have a vertical line. So with vertical lines, remember our slope is undefined, and we only have our x-intercept at 4, 0. So our x value is always going to be 4. Y value, it doesn't matter. The x value is always going to be 4. So we could have a point at 4, 1. We could have a point at 4, 5. Our x value is just always going to be 4. So we always have that point there, and the vertical line passing through. So domain and range are going to look a little bit different here as well. So remember, domain, we always have our x value of 4. That does not change. But our y value, remember, as we're going up and down, it can be anything. So we're looking at all real numbers. For the degree, remember we said our slope is undefined. This is not a function. So it will not have a degree. And then for this one, our end behavior, the x is constant, where y approaches your negative infinity and positive infinity. So it's a little bit different. If you have something like numbers 15 and 16, I'll let you look on Blackboard for those. These are the other forms. They're not in one of the specific 3 forms that we talked about, but we do have linear functions. But for these 2 types of equations, this is where you can make a table to graph. So you can choose values for x, plug them in, and solve for y. So if you want x to be 2, 4, maybe let's throw in a -6, substitute that into the equation, solve, get those points, and plot them. And then that will probably be the easiest way to get that graph. All right, and then we can work the other way, and this is what we're going to get into more tomorrow. Can you take the slope in a point or the slope in the y-intercept and use that to write an equation in a specific form? But we can look at this real quick and see for number 17. We'll just do this one. If we have a slope of 2/3, and then we have a point at 1, -7. So 1, 2, 3, 4, 5, 6, 7. We're down here at the very bottom with the slope of 2/3 counting up 2 to the right 3. Oops, there we go. And then up 2 to the right 3. We can see our line. We can see the end behaviors and everything else, domain and range. So we know that's all real, 1. And then we can say that our x values decreases and our y value also decreases. As our x value increases, so does our y value. But can we take this and put it into an equation? Well, if we're given a point and a slope, then we can use point-slope form. And say y minus our y1 value, which was 1, is equal to our slope of 2/3 times x minus our x1 value. And I wrote the y value in the wrong spot. Sorry. So y minus our y1 value, which was -7. So y plus 7, now that we fix that, equals 2/3 times x minus our x1 value of 1. There we go. Now we fixed it. So now we have our equation in point-slope form of y plus 7 equals 2/3 times x minus 1. And again, tomorrow we'll get more into writing the equations and then changing to the different forms. So can we write that in slope-intercept form and standard form? Again, you can check all of your answers on Blackboard. Send me an email or a remind message if you have any questions, and I'll see you back in class. Bye.